Hey guys, this is Mike, and this is an Android game development series. This series is going to show me creating a game from scratch, step by step, and I'm going to be showing you all the code associated with it. This is going to be a more in-depth version of the last one that I did, which I didn't finish. I know, I'm sorry about that. So I kind of left it hanging there, and I feel bad about it, but I am going to finish this one, for real. So this is going to be more tutorial-like than the other one because in drifting all I did was show you like what features I added and then how I pretty much just tried to build the game. But here I'm going to actually show source code. So I'm going to assume you already have Eclipse and the ADT plugin along with the Android SDK. If you don't, you should have those before you get started. So back in the libgdx website, go ahead into downloads here and grab the setup app. This is going to give you gdx.setup.jar, and you just double click on it and you'll get something that looks like this, the libgdx project generator. And this is going to help you set up all the files that you need to create the game. First off, I'm going to put all of my project folders into this directory here. I called it OMO because that's going to be the name of the game. Don't ask me why it's called OMO. I don't know. I really don't. Anyway, so the name of the game is OMO. Put your package in there, whatever you want to call it. The game class is just OMO, I guess. Destination is going to be here, libgdx OMO, wherever you want to put it. I made a new folder for where I want to put it, so that's what you put in here. And the Android SDK, if you don't have the Android SDK, you can't do any of this. So again, if you don't already have the Android SDK and or Eclipse with ADT, go get those right now. So just put the Android SDK here. And this libgdx version at the time that I'm doing this is 1.31. 1.3.1 is the latest. Let's see, sub-projects. We're going to need the desktop, Android, no iOS, and no HTML. Extensions, don't need bullet. Free type. I guess free type would be useful, but I don't think we're going to be needing it. Box 2D, no. Controllers, no. Tools, no. Box 2D lights, no. Ashley, I don't even know what that is. Lightweight entity framework. Okay. Yeah, that's not going to happen. So once you have all these settings done, you just click generate, and it'll start with this little pop-up down here, text field, text area thing, and this could take quite a while. So just be patient with it. You'll note that it's done when it tells you that you can import the project files into Eclipse or something. Configuration on demand is an incubating feature. I don't even know what that means. This message means nothing to me. So okay. So it says build successful. So that's when you know it should be done. Took 31 seconds for me. So now I can just go ahead and import it. All the project files should be in here. There they are. Gradle, Android, Core, Desktop, and Gradle. And a bunch of other stuff. Anyway, so go into your Eclipse with ADT. You're also going to need Gradle, the Gradle plugin for this, so my bad if I didn't mention that before. You need Eclipse with ADT and Gradle plugins. So here, just go into the Package Explorer, import, and you're going to want to import the Gradle project. Over here, you want to browse to your libgdx, wherever you put the project. I put it in C libgdx OMO, and you have to click Build Model. Again, this is going to take a while. To install Gradle and stuff. If this is your first time using it, then it might take a while because it's downloading a lot of stuff. But if you've already done it before, then it shouldn't take that long. let's see, configuring stuff. Okay, once you have those down, just import these three. I don't know what this parent folder is for, but whatever. That, finish, and again, some more waiting. While we're waiting, why don't we check out the details? Oh, it just shows the job. Imported Gradle projects. That's not details. Piss poor details. Alright, so I'll just wait for this thing to load up. Okay, so once you have your 3 projects up here, you should be good to go. Since this is a new workspace for me, I'm just going to change some settings around. So window preferences. First thing I always do is go into Run Debug, Launching, and I always change to Always Launch the Previously Launched Application. Click this a lot, and that should be good. So now every time you press Control F11, it'll launch whatever you launched last. So over here in desktop, I'm going to go ahead and launch this, the desktop project, as a Java application, and it will launch that one every single time. So here's your default libgdx application. It's just a red screen with the bad logic logo. And if I press Control F11, it should just launch that. Okay, that's fine. So now we're going to go into our core project over here. This is where all the magic happens. Let's go into our OMO file. This is our entry point, pretty much, for the core project. Let's get rid of all of this stuff, except for create and render. You can still use those. Alright, first thing we want to do is set up all the GDX OpenGL stuff. So gdx.gl.gl clear color, or where is it? Clear color. I'm going to change it to a dark gray, because this game is going to be dark. So 0.2.2.21. That's a dark gray. For people who don't know, this is RGBA, red, green, blue, alpha. So that's going to be the clear color. And over here in render, the first thing I'm going to do is I'm going to clear the screen. gdx.gl.gl clear, and I'm going to use gl20.gl color buffer bit. Alright, so if it's something other than GL20, then use whatever, but I'm using GL20, so GL2. Anyway, so this should change everything in our game to just a dark gray, like this, pretty much. Alright, next thing we need, dimensions. This is going to be for the this is going to be our game dimensions. Public static final int width. I want it to be portrait, so it's going to be 480 by 800. Most of my Android, anything I do on Android games, I usually just use 480 by 800 or 800 by 480, depending on portrait or landscape. But this is going to be the actual window, the game dimensions. This is what we're going to use for the camera. This isn't the screen size. This is just the game dimension. So might as well put the title up here also. Public static final string title. It's called OMO. And let's go back to the desktop launcher. This is going to be the last time we're going to go into this desktop launcher here, hopefully. So we got the configurations. We're going to just set the screen size here to width is equal to omo.width divided by 2. It should be just omo.width and omo.height, but if I do that, then you can't see it in the recording. So I'm just going to change the screen size to half of that. Anyway, config.title is going to be omo.title. Cool, so now if I run it, there we go, OMO. It's 240 by 400, and it's got that icon, and that's pretty much it, just a dark gray background. Okay, so this first video is going to be setting up the base structure for the entire game. And by that, I mean game states and game state managers. If you already know about game states and game state managers, then you can skim through this part, but I'm going to be using Paint here to illustrate with fancy drawings about what I'm talking about. So first of all, let's go ahead, close out the desktop. Never need that again. Everything is now going to be in core. So let's add a new package and call it states. This is where all of our game states are going to go. And okay, another thing I'm going to do is change the package presentation to hierarchical, because that makes more sense to me. So over here in the states package, we're going to add a new class called state. This is our base state. It's going to be abstract. We don't want to create any instances of this. We just want to subclass off of it. So state, being the subclass, the parent class, superclass, whatever you want to call it, is going to need protected fields. Actually, before we get started with that, let's go ahead and make our game state manager. Just call it GSM, because typing out game state manager every single time is bad. It just takes way too long. Public GSM, here's our constructor. First of all, our game, let me just explain real quickly what game states are. You can skip this if you want. Game states basically, okay, so game basically is a loop, right? That's all the game is. The game does an update and it does a render. That's how I always think of it. Just an update and a render, that's it. And it does this over and over and over again, 60 times per second, usually. So basically, since the games usually are composed of a lot of different things, so you want to maybe organize your game into different sections. For example, you want the main menu to be separate from, let's say, the options menu or the high scores menu. What you do is you create game states so that each game state has their own update and render methods, like this. And the purpose of the game state manager is to keep track of all of the game states that you create. And the purpose of that is to just update and render any game states that you want to be updated and rendered. For example, if you only want one at a time, like this could be our menu, the top one, so the GSM will update and render only the menu state. And then it'll loop, and then it'll keep going like that. And then eventually, let's say you press options, and then it goes to the options state. So now this one is going to be updated and rendered only, and it loops again, and so on and so forth. That's the point of game states, is to organize everything into different blocks, and each block having their own update and render. So that's what this is all about here with the game state manager and the state class. So for game state manager, we're going to be using a stack structure. Make sure you import Java util stack, because I have no idea what this other libgx stack is, if it's the same or what. So just use stack from java.util. So first off, why am I using a stack for my game state manager? I think stacks are pretty cool for handling game states. Remember what a stack is? A stack is you pop one at the top, or you push one to the top, and then you push another one on top of that, and then you pop it off. So the first one in is always the last one out. That's the kind of structure it is. So when our game state manager first starts up, it's going to have an empty stack. So in the constructor, let's go ahead and do states is equal to new stack, stack of states. So our game state manager is now just simply an empty stack. What I want to do is I want to push states onto the stack. So let's say I push the menu, and all of a sudden our stack has one menu at the top. And let's say I decide to go ahead and push options, then our stack is going to look like this. Menu, oh no, options first. Always the last one pushed is always the one at the top, then menu. So that's what a stack structure pretty much is. You can also pop, And what pop does is it removes the very top of the stack. So pretty much that just gets rid of the options menu and it goes back to just menu. Okay, so that's pretty much stacks right there. Let's go ahead and implement these stack operations. We had two of them. The two important ones are push and pop. Public void push. We're going to push a new state into the stack. So states.push s. That's push. And we also have the second operation, which is pop. Poop. States.pop. Okay. So that's pretty much it. Hopefully everyone is familiar already with stacks. If you're not, you should probably read up on those because it's a really, really common data structure. So for convenience, we can also create another method called set, and all this does is replace the top of the stack. How do we do that? Well, it's really simple. First we pop the top of the stack off, and then we push. So a set is simply just a combination pop and push, because all it does is replace the top of the stack. Alright, that's pretty much it. Now remember what I said before, that the game state manager is responsible for updating and rendering only the game states that are required. Our game state manager is only going to be updating and rendering the top of the stack. So public void update float dt and public void render sprite batch sb. We're only, in order to get the top of the stack, we use something called peak, and this is going to give us the very top of the stack. First off, let's go back into state. Every state is going to have a reference to the game state manager. That way the state can tell the game state manager to switch to another game state by using push, pop, or set. So let's go ahead with the constructor over here. The state basically just takes in a game state manager reference and sets it. Simple stuff, and it also needs two important methods, update and render. Every game state has to have their own update and render. So I'm going to make it abstract just to force you to override it. That's update with a float argument and render with a sprite batch argument. Alright. Import. It's not importing. Why are you not importing on me? Oh wait, I spelled it wrong. That's why. Sprite batch. There we go. Okay. I also like to create a third one called handle input, just so I can keep the input away from the update and render. So all in all, every state is going to have these three methods: handle input, update, and render. So in our game state manager over here, remember our game state manager wants to update and render only the top of the stack. And we get the top of the stack with states.peak. So states.peak.update is going to update the top of the stack. Likewise with render, states.peak.render is going to render only the top of the stack. Now this is as simple as you can get with a stack-based game state manager. You can make it do something else. You can have a game state manager that updates and renders more than one game state if you want, and you're going to have to figure out that by yourself. So keep it simple for me. Only the top of the stack should be updated and rendered. Alright, now that we have our state and game state manager, let's go back into OMO. So now we should have these three classes: OMO, GSM, and state. If we go back into OMO, let's go ahead and use our game state manager, GSM. Import. Okay, so let's create the GSM here. Oops, new GSM. And move this down. Okay. What our game state manager is going to do is simply just update and render. graphics, I think it's in here. Yeah. Get delta time and GSM.render using the sprite batch SB. Oh, we don't have a sprite batch yet, so let's just create that. Private sprite batch SB. Up there, import it, create the new sprite batch. Okay, and pass it along. So this render method gets called 60 times per second, I think, with the GDX. This is our game loop. So it's going to call game state manager update and render every single time. And the game state manager is only going to update and render the top of the stack. So right now, all we did is create a new game state manager, which has nothing in it. It's just an empty stack. What we have to do is we have to push something onto it. So let's go ahead and create our first game state that we will push onto the stack. Let's go ahead and create test state. I'll just call it test state because it's a test. I put that in the states package. So extends state. Now over here, let's go ahead and create the constructor, taking a game state manager and calling the states constructor with super GSM. And like I said before, state needs these three methods: handle, input, update, and render. You can go over here and add unimplemented methods to make it quick. I usually just type it out because I don't want all this at override / to do stuff. I don't know. We'll see. Anyway, so we have these three methods set up, and that's our test state. So what we're going to do is we're going to push this onto our stack. So back in OMO, when the game starts up, we're going to push this. gsm.push new test state. Remember, every game state takes in the game state manager as a reference. New test state GSM. So now we have one test state at the top of the stack, and that should be the one that's getting rendered and updated. So we're going to test that. Over here with a print statement, we're going to do test state updating and test state rendering. And I'm going to move the console up. No, I'm just going to drag this up here. Okay, so if I run this now, it should just say test state updating and rendering. There we go. That's pretty much it. So yeah, that's going to be it for this video. This is just the basic structure. Now that we have all our game states up and running, we can actually begin working on the game in the next video. I'm just kidding. There's actually more stuff that we need to do, like input, but after that, that should be it. So the next video is just going to be input, then after that we will start making the game, which I haven't even explained yet, but hopefully you'll keep watching and find out what it is, because I have a very clear idea what the game is going to be. So thanks for watching.